This is example 10-5, flow through pipe expansions. We have air flowing through this expansion right here. Looks a little bit like half of a muffler. We're given what the air temperature is at 4 degrees C. We know what the velocity is at A. And we're now asked to find the pressure difference between A and B. So because we have losses in here, we of course need to use the energy equation. So let's write the energy equation. Energy equation. So we get PA over gamma plus VA squared over 2G plus ZA plus H pump plus PB over gamma plus VB squared over 2G plus ZB plus H turbine plus HL. Let's start as usual with a datum. So we can say it's a horizontal pipe. Horizontal pipe, which means that ZA is equal to ZB is equal to some Z. I'm just going to cancel out later on anyway. So that's that. What else do we know? We know we have no pump or turbine. Or turbine means H pump is equal to H turbine equal to 0. PA's or PB we're going to look for. Okay, velocities. We're given VA, but we're not given VB, so let's calculate VB. Use continuity for that. So you can say VA times AA equal to VB times AB. That means VB is going to be AA over AB times VA. These are circular cross sections, so pi over 4 dA squared over pi over 4 dB squared times VA. So VB, those cancel out. We can pull them together, so we'd have dA over dB squared times VA. And that is what? So we have dA is 300 millimeters. Yeah, it doesn't look like millimeters, it looks like something. 300 millimeters, and dB is 800 millimeters squared times 15 meters per second. And that gives me 2.10935 meters per second. So that's my velocity. So I have PA, BB, VA, VB, ZA, ZB, pump and turbine. So only the losses. It says only to look at the minor losses at the expansion. So minor loss at expansion, right? That is HL is equal to KL times VA squared over 2G. Choosing VA here because that's the smaller diameter, and at the expansion we all use the smaller diameter. So we also know what KL for this type of sudden expansion is, right? That's 1 minus dA squared over dB squared times VA squared over 2 times G. So let's plug in some values here. 1 minus, we can do the same as we did up there. So that would be 300 millimeters over 800 millimeters squared, and that squared times VA, which was 15 meters per second, divided by 2 times 9.81 meters per second squared. That gives us 8.46938 meters of head loss. That's quite a chunk. So now let's go back to our energy equation. Right now we have all the terms in here, so we can write the terms down here. We have PA over gamma. Then we have VA squared over 2G. We have whatever Z is. We don't have anything from our pump. Equal to PB over gamma plus VB squared over 2G plus Z plus 0 from our turbine, and then plus HL. All right, so if we want to solve that for PA minus PB, then we would have to bring over PB. So PA minus PB over gamma is equal to that's gone. So we have VB squared over 2G. We get the negative VA squared over 2G. The two Z's cancel out, right? Then we have a 0, so all left is plus HL. That means we have PA minus PB over gamma is VB squared minus VA squared over 2G plus HL, and then we can multiply by gamma. So we would get PA minus PB is equal to gamma times VB squared minus VA squared divided by 2 times G plus gamma times HL. Okay, we can simplify that just a little bit here. Right, that is equal to rho over 2, right, because gamma over G is rho. VB squared minus VA squared. Plus, we're also not given gamma, so rho times G times HL. All right, with that, we can go and look up what the density is for air at 40 degrees C, and then we can plug in all the numbers. All right, so we have PA minus PB is then equal to 1.127 kilograms per cubic meters divided by 2 times the VB that we calculated. Right, that was 2.109375 meters per second squared minus 15 meters per second squared, and all that minus minus minus, where do I have, you can have a wrong set up here somewhere. So it should be plus, not minus. Anyway, typo in my solution here. Alright, so there should be a plus. We'll have to edit that as we go along. Plus our rho 1.127 kilograms per cubic meters times 9.81 meter per second squared times our HL, which was 8.469,328 meters. And so now I need to do the math real quick because I had a wrong sign in there. So 1.127 divided by 2 times 2.109375 squared minus 15 squared plus 1.127 times 981 times our 8.469328. That leaves us minus 30.5489 pascals for our pressure change. All right, so we can see that the pressure at B is actually slightly larger than at A. That's because we get this big change in velocity. Right, so that's the reason why we get that change.